In this video, we're going to be talking about Pythagoras' theorem. Pythagoras' theorem is mainly used to determine the length of one of the sides in a right-angled triangle. But before we look at Pythagoras' theorem, it's important to look at how you'd label a right-angled triangle. The longest side in a right-angled triangle is always found opposite the right angle, and this side is called the hypotenuse. The hypotenuse is very important when it comes to Pythagoras' theorem, which you will see later in the video. Now, consider a random and new right-angled triangle, like the one shown in front of you. To apply Pythagoras' theorem to this triangle, we must label the sides like this. The hypotenuse always gets the label C, and then you label the other sides A and B. Now, to help you understand and remember Pythagoras' theorem, I will show you one of the ways to obtain the main formula we use. Imagine drawing a square next to each side of the right-angled triangle, where the side length of the square is equal to the length of the side of the right-angled triangle you're drawing the square next to. Looking at the area of the squares we have just drawn, we can see that the area of one of the small squares plus the area of the other small square is equal to the area of the largest square on the right-angled triangle. In the example shown, that is 9 centimeters squared plus 16 centimeters squared is equal to 25 centimeters squared. You may now note that the area of a square is equal to the length of one of its sides squared, and since the length of one of its sides is equal to the length of the side on the triangle it's next to, we can say that the area of each square is equal to the length of the side on the triangle it's next to squared. If we label the triangle like we did before, we can generalise the formula as a squared plus b squared equals c squared, where c is the length of the hypotenuse of the triangle and a and b are the length of the smaller sides. Now we will look at an example of how to apply Pythagoras' theorem in a question. In this question, it is asking us to find the length of the hypotenuse of the triangle in which the smallest sides have side length 6 cm and 8 cm. The first thing we must do in any Pythagoras question is to label the sides, where the hypotenuse gets the label C and the smaller sides get the labels A and B. Next, we want to take a look at our formula. A squared plus b squared is equal to c squared. Plugging in our values for a and b and plugging in x as our value for c, we obtain that 8 squared plus 6 squared is equal to x squared. This is the same as saying 64 plus 36 is equal to x squared, so x squared is equal to 100. Now remember from the question that the thing that we want to find is x, so we want to rearrange for x equals. Therefore we take the square root of both sides of the equation to get x is equal to the square root of 100, so x is equal to 10 centimeters. This is our final answer. Now we're going to look at a second example. If you want to attempt this on your own, please pause the video now. Now, as before, the first thing we must always do is label the sides, where the hypotenuse gets the label C and the smaller sides get the labels A and B. Now we want to take a look at our formula. A squared plus b squared is equal to c squared. In this case, A takes the value x, b takes the value 12, and c takes the value 13. This gives us x squared plus 12 squared is equal to 13 squared, which is equivalent to x plus 144 is equal to 169. Looking back at what the question wanted, we're still trying to find x, so we must rearrange to get x equals. To do this, we take 144 away from both sides to obtain x squared is equal to 169 minus 144, or x squared is equal to 25. Finally, we square root both sides to obtain x is equal to root 25, or x is equal to 5 centimeters, and this is our final answer. In the example we just went through, a different variation of the general formula would have actually been quicker. In this case we would have used a squared is equal to c squared minus b squared, or b squared is equal to c squared minus a squared. This can speed up some questions, however you can still work the answers out just the same by using the original formula a squared plus b squared equals c squared.